Hi, and welcome to the sixth lab session of Computer Networks. We are studying the circuit programming in C, and today's lab session is about the UDP circuits. The User Datagram Protocol, or UDP, is a communication protocol used across the internet for especially time-sensitive transmission, such as video playback or DNS lookups. Unlike the TCP, it speeds up communication by not formally establishing a connection before data is transferred. And owing to no connection requirement, this allows data to be transferred very quickly. But there is also a drawback, and the drawback is it can cause packets to become lost in transit. Like the TCP or other networking protocol, UDP is a standardized method for transferring data between the two computers in a network. Compared to the TCP, UDP accomplishes this process in a simple fashion. It sends packet directly to a target computer without establishing a connection first. That was done by the TCP using three-way handshaking technique. It also doesn't care about the order of the packet to be transmitted correctly or not correctly, and it is not checking the sequence number. UDP is faster but less reliable than the TCP. We saw in the previous lab that the two computers began by establishing a connection using this three-way handshaking technique. First, it was starting with the synchronization, then the synchronization was acknowledged, and when it was also acknowledging, and after that, these two computers were ready to communicate. And these TCP handshake are used for the connection establishment. Once this handshake has been completed, will only one computer actually transfer the data packets to the other computer. UDP communication do not go through this process. Instead, one computer can simply begin sending data to the other. In addition, TCP communication indicates the order in which the data packet should be received and confirm that the packet arrived as intended. If the sequence number first is packet number first is received and acknowledged here, then the sequence number 2 should be there, and then the 3 and 4 and so forth. And if a packet does not arrive due to congestion or some other problem in the way, TCP requires that it be resent. However, the UDP communication do not include this any of this functionality. These differences create some advantages because UDP does not require a handshake or check whether the data arrives properly. It is able to transfer data at much faster rate than the TCP. However, this speed creates trade-off. If a UDP datagram is lost in transit, it will not be resent. As a result, applications that use UDP must be able to tolerate errors, loss, and duplication. So the following are some characteristics of the UDP. So it belongs to the layer 4, the transportation layer, and it does not do any segmentation, but it keeps doing the single packet transfer. But TCP, on the other hand, it was doing the segmentation transfer, and there is no error detection and correction. So there is something called the detection with checksum, but it is not corrected. It is only for detection. As I mentioned in the previous slide, it is connectionless protocol, which means there is no synchronization, there is no acknowledgement and things like that. There is no sequence number and no flag fields in the packet. There is no congestion control. So as long as the sender wants to transmit the data to the receiver, it will keep sending the packets. No matter they are colliding with each other, there is a congestion in the way, or the link is very bottleneck, or the packet are dropping. Regardless of that, it will keep sending. It's commonly used for broadcast. Previously, and even nowadays, it is considered very favorable for the video broadcast or for the gaming purpose. But nowadays, that trend is also changing. Most of the video broadcasting is going to the TCP. So the TCP is handling the video transmission to make it more reliable. Some specific purpose of UDP ports are like for SNMP It is using 161 port, or TFTP, it is using 69 ports. So these are the dedicated ports for certain applications, but for the other, you can just define your own ports as like you were doing for TCP, and just like that we can transfer the data. As I mentioned you earlier, like previously when we were dealing with the TCP, there was a connection establishment before we were sending the data. So the before sending the data, both the computer had to go through the three-way handshakes. And once the three-way handshake was completed, then the data was transmitted between the two computers. And once the data between the two transfer between the two computers were completed, they were sending some finishing, sending and acknowledging and all those stuff that we saw in the previous lab, and then the connection was over. However, here in the UDP, a single socket is created for the client side and also for the server side, and which can receive the data or sends the data with multiple hosts. So let me show you the previous example, and the Echo client and the Echo server. So previously, if you remember, we had the Echo client and the Echo server. The Echo server was starting with the, for example, we were using the port number 1122. I will allow it. And then we were we were using this client from here, and whatever we were writing there, it was received here. But when we were cancel but we want when we wanted to cancel this connection, it was the connected to the client number 1, but at the same time we wanted to reconnect to that one, then another connection was established there. And since, if you remember, I show you the code, there were the 5 connections. So a client from a single client, it was accepting 5 connections there. So as long as there was a connection from there, it was working like that, and the server was responding as an echo server. If I again cancel it, the second connection is finished. Now when I'm establishing a connection again, then the third connection is established here, and during this establishment, this will send a sync, and then it will acknowledge, and then it will also acknowledge, and then the data transmission starts. So this much time is taken between the two. And then if I can cancel it again, and then I run it again, I cancel it again, and then if I do it again, then this is the last time, and if I cancel it, then this will be finished because the for loop is running for the 5 iterations. But we will see in today's lab that this thing will not happen. As long as one is going to send a packet to the other, this will be the connection will not be established, but it will simply transfer the data to that one. I also wanted to tell you one more thing. For example, my server is running here, and if my connection is established from here, and then I also want to make a connection to be established from the other one. Let me zoom it. So this one is not responding me. See, it is not working because already the connection is established here. Until and unless I quit from here, I quit this one, sorry, I quit this one, and then this connection is started here. It will be responding. But when one connection is there, the other will, even if the other one wants to establish a connection, it will not be responded from there because it is now connected with this one, and this is not being responded. So if I cancel this one, then it will be responding to that one. So in this way, at a time, it can respond to a single one connection, and if there is another one, if it want to communicate with this one, it will not be able to communicate. Why? Because it is already in connection with that one. But this thing will not happen here. If there are multiple computers that are multiple clients that concurrently wants to communicate with the server, they can communicate. This one can also communicate with this one, and this one can also communicate with this one at the same time. One other difference between the UDP and the TCP is we were first establishing a connection between the TCP server and the TCP client, and once there was a connection established, then we were simply using the right method to send the something. But here we have to use the send to. So each time when we want to send the data from the buffer, we have to specify the socket address, and then we have to use the send to. On the other hand, if you want to receive something from the destination, then again we have to specify the socket address of the destination, and then the any data coming from that buffer should be received and the receive from. So the receive from is something that is used for the computer that wants to receive the data from the destination, and send to is a function that is used for some data to be sent to the destinations. And again we have to use this header file. We saw the previously what was the TCP Echo Client and Echo Server. So what I'm planning today to use the same TCP Echo Client and Echo Server files and then reduce it to the UDP based Echo Server and Echo Client. So we will see all these things on step-by-step basis. Please remember, in the TCP we were using the segmentation, but here it's not like that. We are, as long as we have a message, we have to specify the message and the address of the destination socket, and then we have to send it. If we have another message, then we have to specify then we have to send another message to that particular address. So we have to use simply the send to. But on the other side, if we have to receive it, for example, we want to receive something, but here we also use the delay for 5 seconds. So the delay for 5 seconds will be there, and it is running for 3 times, and each time it is, when it is receiving something from here, it will be printing it with the 5 seconds of delay. So we will see this thing in more details when we are doing some practicing examples. Now let's go to our code, and firstly I will have a brief review on the TCP client and the TCP server, the TCP Echo server, and then we will start with the UDP Echo client and the UDP Echo server, and finally we will do the bound host and the bound host 2.c. So let's start it. Okay, let's see the file from the previous Echo server and the Echo client for the TCP. And since we have already done the TCP Echo client and the TCP Echo server, then we will reduce it to the UDP. Firstly, if you look at this one, firstly we defined the header file, and then we started with the main body of the program. And the main body of the program, the server side, there were the server socket and also the client side. But in the client side, if you look at there was only one socket only for the client. Since the server is also responsible to get something from the client, so that's why we declared one for the client, and then we declared some message buffer and also some other additional things that we had declared here. Then we put for the ARGC, since there were two things involved here. So if it were not equal to 2, then we were asking that your statement is not correct. Or for example, if someone were entering only this way /server, and they were not entering the port address, then in that case, then there would be an error message. So the port address is also required there. And then we were creating a socket, and for the socket creation it's the same almost every time we are doing it with the TCP IP version 4. And then we were also getting from the input, we were getting the port number, and then we were binding the structure of the IP address and also the port to itself. And once it was bound, then we were listening at that particular socket. And when we were listening, we were saying that there should be at least 5 clients requests coming from there. So if there are 5 requests, keep accepting it. Once we reach the 5, then just simply finish the request, as we said just a while ago. Since the connection is established here, we will only write the anything coming from the client side. So the client is continuously sending some message there, it is reading it, and then keep transmitting it towards the client socket address. And then we are closing the client socket, and also we are closing the server socket. On the other side, if you look at here, we have two arguments. One is the this one, the other one, and the third one. So we have this condition here, and then we were creating the socket, and after the socket we were also binding it with the IP version 4 address, and also with the port number. And once that was there, then we were making a connection request towards the socket address, which was the destination. And when there was a connection establishment, then we were writing something towards the server, and in response we were reading something from the server socket, and finally we were printing out that message, and we were then closing the socket. So let's go back to the server and let's make changes so that to make it a UDP socket. I already explained you the main difference between the TCP and UDP, and now let's see what could we do to convert it from the TCP to the UDP. So again we will have some error messages, so we will keep it as it is, and then we will start with the main, and again we want to get the input from the users, so we will keep it also like that. And since I told you there is no need of connection establishment, so I should just keep the server socket, and then it's a buffer. Let me make the buffer size a bit smaller, just for simplicity. We don't have a client here, so I will just simply remove the client. And again we have two input arguments, so I will keep it because we have 1 and 2. So again we have two input arguments, so I will keep this one. If they are not equal to 2, there should be an error message. And now we have the server socket creation, and for the server socket creation, again we should have AFINet, but this is not a sock stream. Sock stream is always for TCP, so I will make it a sock datagram. So I will make a DGRAM, sorry, GRAM, and it is not S, it is D. So I will make it sock datagram. Now the packet will be transmitted in the form of UDP, and I will keep it 0. Then again, if there is no socket creation, if it is equal to -1 means that there is no socket creation, then there should be a UDP socket error. Let me write down UDP also. UDP socket creation error. Okay. Yeah, I'm sorry for the capital and small, but just leave it as it is. And then we are doing the same thing. I'm using the version 4 AP internet address, and then I'm using this one, and again I'm taking the port number from the input argument, so let's keep it as it is. And finally we will go to the binding stage. So again the binding is quite similar. We have the server socket, and then we have the sock address, which we will take from the structure. And then just if it is not equal to if there is nothing, then give me an error, and if it is bound, then go to the listening. So here I'm not doing any listening, so I will just simply um, delete this part, and I will start with the uh, while, oh sorry, let me turn off the caps lock, while, and I want to keep it for infinity amount of time. So let's keep running it for infinity amount of time. And then so I have already declared this one, and I will keep it as it is, and then I will add one more line. So I'm receiving a message, anything coming from the client address and the client address size. So anything coming from there, just receive it in the buffer. Just to show everything on the screen, I will enter it and give it some tabs so that everything can be visible on the screen. And once I receive the message from the client, I want to make it an echo, so I should send it back to the client side. So I should do the same thing as I explained you. Sorry for forgetting the semicolon, so you have to take care of this one. And then finally, I think we are done with this, so I will just close the while loop, and finally I will delete everything from here, so I don't need it anymore. And then I will just close the server socket, since I don't have the client socket open, so I don't have to worry about that. And then I will return 0. So my echo UDP socket is done. Let me save it with a different name, because we will also need the other one. So I will make it U underscore echo, UDP echo socket, UDP echo underscore server dot C. So I will save it like that, and then let me save it before it is saved in the U underscore U, this one. So let's make the corresponding changes in the echo client too. Again, we will need this header files, and then since I used the 30 size buffer, so I should also use it here. And then I will start with the main argument, the same as that one. So let me call it sock, and then again I will need these variables. So in addition to this one, I will also add another variable, from underscore ADR. And then if again we have three things here, so if argc is not equal to 3, then in that case it should ask me this question and it should exit. Then I think I should keep this one. And then we have the socket creation. So again I have this one, but instead of stream I should have the packet datagram. So sock datagram, sorry. So dgra. And if there is no socket created, then I should have the error, and I have already defined the error before, so let's keep it here. And I can say that the client UDP sock error. And then again I should do the same thing. I should just bind the IP address and also the port number with this structure. I don't need any connection to be established, so I should delete this one like that. And then yeah, if I want to quit, I should just put Q, because the loop is running for infinite amount of time. So also put this one condition here, and if someone either click on Q, small q, or big Q, it should just break this while loop and go out of this one. But instead of write, we should use the send to. So I want to send the message that is contained in the message buffer, which is this one, to the server address. And instead of doing read here, I should receive it from the receive from. And since we use the from address here, so instead of the server address, we should just put from address, because we are receiving something from address. And finally, we should start the this thing from the 0, otherwise it will start from some garbage value. To avoid that, we should start it from 0, and we should print it out. And finally we should close this socket. That's it. So we have the UDP echo client and UDP echo server here. Now let's execute the file that we created, and then for the server and also for the client. And finally we will have u client underscore echo.exe and u server underscore echo.exe. So let's test it and see if it works. So if I go back to the U client, and uh, let's assume that I'm using some different kind of because I think even in previous I used 1122, so you might be thinking that why I'm using always 1122. So let me just do like 3131. Okay, I see. Assuming that you have not, I wanted to show this thing to you later, but now it came first. So mm, since even you are running this thing and this client is executing but the server has not started yet, so if you want to click on this one, there will be no response because there is no server connected, right? So it will not give you any response. And if you want to make it work, then you have to first run the server. um, Okay, first you have to run the server. So I'll run the server here now. Oh, again 1122. So let's see. Let me remove. Let me remove the 1122. I want to use some 3131. Enter, and now my server is listening at that port. And now let me um, run from the client here. Sorry, uClient underscore 3131. And now whatever I write here, I should get a response back from the server. So it's an echo client. So the message will go there to the UDP server, and the UDP server will uh, receive from first and then send to back. And the UDP client is doing the send to first and the receive from later on. So if you look at here, if you look at the, let's see the client. So the client is doing send to first and receive from later. But on the other side, if you look at the server is doing receive from first and the send to later. So both are doing it vice versa. Um, I want to write some more things, and as long as you are writing, it will be bounced back to you, which means it forms an echo. But as I mentioned you earlier, because why it is different from the TCP. So let me enlarge the fonts, and let me connect it also to the 3131. So 3131, and enter it. And if I want to type something here, it's also responding. So if I have more clients here, the same thing, it is also bouncing back, and the same way it is also bouncing back. So both are echoing. This is also going there and then coming back, and this one also going there and coming back. But if you look at the TCP, I forgot what was the name for the TCP. Sorry, um, server. Okay, I think, yeah, I think it should be only server.exe. Yeah, let's see. /server space and 1111. If I connect it, the server, like, oh sorry, it was the previous one, so it's not the one. I'm sorry for that. So there was echo server, echo client, and echo server. Sorry for the confusion. And I will just do echo underscore echo server and not with exe. And let's say I'm listening for, at the echo server at the port number 1111, and then I'm executing the echo client here. So /echoclient, but I should not use the .exe, and then I should use the IP address and then 1111. So the client one connected, and as long as I'm writing from this one, I will be receiving back. But if I want to use another client using the same echo server, sorry for this one, and let me use the okay, let me type it down. Echo client and again 127.0.0.1 and then 1111, and then If I want to write, it will not write. Why? Because one is already running there. So in TCP at a time, one should work and the other is not working. So if I'm doing it from here, it still works, but from here it will not work. But if I close this one down, then the connection started, and then if I write something, then I'll be returning that thing. But this thing is not happening here and the UDP side. And the UDP side, as long as you are connected, you will still be able to listen from the two clients. So that's it for the client side. And let's see some other examples. Now, rather than an echo client and echo server, let's see some different example. So again, we started with the header file, then the main body of the program, and then there are some variable declared. So everything is the same as we saw earlier. And then this one is kind of server, so that's why it is bound underscore one host one. That's why there are two input argument, which means that it will take one from the name and the other will be any number for the port address. So if it is not equal to that, then there should be an error. And then finally we will create a socket, and once the socket is created, we will bind it with the IP version 4 address and the also the port number. And after doing that, after binding and everything, then we started a counter for 3 times, which means that anything coming, it will check it starting from 0 and up to 3, and then it will keep incrementing. But before reading the message from there, first it will take a delay for 5 seconds. So after the 5 seconds of delay, then it will receive whatever the first message from there is, and it will display it. And then again it will go to the loop and it will check this. Since the condition is not correct, then again it will go and sleep for 5 seconds or take a delay for 5 more seconds, and then it will display the second message, and finally it will display the third message. And to display the message, it is printed from the buffer, which is here. And if we just look at the client side or the other side, let's assume we are not calling it server and client, but the one with two arguments, that is considered to be the one to which we are going to send the data, and the one with three is the one which is sending the data, right? So we are declaring three kind of chars, and the message one, we are just transmitting a message like hi, and the message two, we are transmitting I'm another UDP host, and then in message three, I'm just writing like nice to meet you. So all these three messages are created here, and then just the conventional things that you have seen quite for a while. And then also you are creating the socket, and then what are you doing here? You are just doing send to the message number one and to the address of that host one, and then the message number two, and then the message number three. As long as you are sending the messages, it will be, if you remove this one, if you remove the sleep 5, it will instantly receive there. But since you have a delay 5, so what will happen? Firstly, the first message will be displayed, and then the loop is running, then the second will be displayed after 5 seconds, and then the third will be displayed after 5 seconds, and finally this program will be finished. So let's check and see if it works. So I'll just clear it, and before I will just make an executable files, and since I have already done it, but just for you, I will call the other one bound2, the bound underscore 2.c. I will call it bound2, and the other one I will call bound1. And once they are created, since there is no error, so I will just say that let me connect the bound 1 to 1 to 1 to, since there were two input arguments, so it will take the input here. And if I want to call that one, I have to put this address, IP address of that one, and then the 1 to 1 to port. So you can see It already sent the message, but the message is going to be delayed for 5 seconds each one. So hi is displayed first, I'm another UDP host as the second, and nice to meet you as the third one. So this is another very nice example, and you can do a lot of things with using the UDP and TCP. It's a lot of fun. So we covered this example also, and we did this one. So far we were talking about the connectionless UDP socket, but it's also possible to have the connected UDP socket. For the connected UDP socket, you don't have to specify the destination IP address. So and that time when you are using connected, you don't have to use the send to, or you don't have to use receive from. You can use the read, receive, or receive message in that context. But for the connected UDP socket, there can be some asynchronous errors. But this issues is only with the connected UDP. Since when we have unconnected UDP or connectionless UDP sockets, there we don't experience such kind of asynchronous errors. This is the end of today's lab, and I'm gonna also upload some homework for you. I should also evaluate your progress now. So maybe by before this weekend or during this weekend, I will upload some assignment homework for you, and you can please check it. And I will also put the deadline for that. So within that deadline, please submit it back, and then I will evaluate you based on some homeworks. So it's not the from last first and last homework. So I might give you some more homeworks. So please do it in time and submit it. I will also give you the procedure, the detailed procedure how to submit it, and then I will evaluate you on based on that. Thank you very much for having your attention, and I'll see you in next lab. Bye bye.